Ladies and gentlemen, ladies and gentlemen, ladies and gentlemen, ladies and gentlemen, hello, ladies and gentlemen. Before we begin, please ensure that you are on mute throughout the webinar to minimize the background noise. If you have any questions, please feel free to type them in the Q&A box, and we will address them during the Q&A session. A very good day to everyone. Thank you for joining us in this International Day of the Tropics webinar. Academician Emeritus Professor Tan Sri Dr. Mazlan Othman, the co-chair of the International Conference on Tropical Sciences, TropSc2024, senior fellows of the Academy, members of Young Scientists Network, Academy of Sciences Malaysia, YSN ASM, and the academic partners and affiliates. Distinguished guests, ladies and gentlemen, welcome to our third pre-conference webinar, part of the Future Belongs to Tropics webinar series. This webinar series celebrates the tropics and the highlights of the importance of the science and technology in the region. Additionally, it serves as a lead-up to the International Conference on Tropical Sciences, TropSci, which the Mahathir Science Award Foundation and the Academy of Sciences Malaysia will jointly host in July 2024. So today's webinar is a joint effort between the Mahathir Science Award Foundation and the Academy of Sciences Malaysia, where we are celebrating International Day of the Tropics with the aim to take stock of progress across the tropics, to share tropical stories and expertise, and to acknowledge the adversity and potential of the region. Before we begin, I would like to invite the co-chair of our upcoming International Conference on Tropical Sciences, TropSc2024, Academician Emeritus Professor Tan Sri Dr. Mazlan Othman, to give her opening remarks. Please welcome.
Okay, I've unmuted myself. Ladies and gentlemen, distinguished guests and participants from around the world, I am very honored to welcome you all to this special webinar in celebration of the International Day of the Tropics, which, as we know, is actually tomorrow, but because we are celebrating Eid tomorrow, and that's why we're having it today. Allow me to recap that this is the 22nd webinar that is being organized in connection with the webinar series of the Tropical Sciences, which we started in 2020. And I believe all these webinars are available for you to check out. Now, so we are talking about the International Day of the Tropics. This day serves as a reminder for all of us about the important role played by the tropical regions in shaping our world. We know that these regions are home to the world's largest biodiversity, as well as cultural diversity. Such wealth should be of advantage for the world, and especially to the region. However, it is crucial for us to acknowledge that the tropics also face numerous challenges. As we know, 85% of the world's poorest live in the tropics. But apart from that, climate change, deforestation, loss of biodiversity, and social inequality are just some of the pressing issues that demand our action and attention and collective action. Today's webinar, I hope, provides us with an opportunity to reflect upon these challenges. And throughout this webinar, we have the privilege of hearing from renowned experts, thought leaders, and practitioners who have dedicated themselves to the understanding, conserving, and promoting the well-being of and the well-being in the tropics. Their insights and experiences should inspire us to forge new partnerships, embrace very innovative approaches, and advocate for policies that foster the sustainable development of the tropics. We hope that this webinar provides the platform for us to collaborate, for us to exchange our best practices, and to generate actionable ideas that can make a tangible difference in the lives of those living in the tropics. As I said, we are deeply honored and privileged to have with us a distinguished lineup of speakers from around the world, some of whom are like 4 in the morning. I'm like so grateful and impressed. So on this International Day, together, let us reaffirm our commitment to safeguarding the tropics and unlocking the vast potential of the tropics for the benefit of humanity and the planet as a whole. So everyone, thank you for joining us, and I wish you all an enlightening and productive webinar. Thank you.
Thank you very much to Tan Sri Dr. Mazlan Othman for the wonderful speech. Ladies and gentlemen, now before I pass the floor to Prof. Dato' Bakar, our moderator for today, to take over, please allow me to introduce a bit about him. Prof. Dato' Engineer Dr. Abu Bakar Jaafar is the Vice President and a Fellow of the Academy of Sciences Malaysia. He is currently a professor at the Perdana Center UTM Razak, Faculty of Technology and Informatics, the Director of the UTM Ocean Thermal Energy Center, Chairman of the Malaysian Green Technology and Climate Change Center, MGTC, as well as the Director and Senior Principal Environmental Consultant of EnviroLift Services Sdn Bhd, NovaViro Technology Sdn Bhd, Aker Engineering Malaysia Sdn Bhd, and HITTS Technologies Sdn Bhd. His area of expertise includes mechanical engineering, environmental science, and marine geography. He is also the co-chair of our upcoming international conference, TropSc2024, alongside Tan Sri Mazlan and the chair of its technical committee. Without further ado, I would like to invite Prof. Dato' Bakar to moderate the session. Please welcome.
Thank you very much, Inani, for your kind introduction. I just realized that you read my old CV. Anyway, I need to update that. Okay, thank you very much for your kind introduction. Bismillahirrahmanirrahim. Assalamualaikum and good morning to one and all across the world. Thank you for having me this time. And thank you all for joining us for different parts of the world to celebrate and explore the significance and challenges of the tropics. Tomorrow, as stated by our Tan Sri Mazlan just now, 29th June, we'll be celebrating International Day of the Tropics. And today it is our aim to take stock of progress across the tropics, to share tropical stories and expertise, and to acknowledge the diversity and potential of the region across the equator. The tropics encompass a vast area of our planet containing diverse ecosystems, rich biodiversity, and vibrant cultures. However, they also face a range of issues and challenges that require our attention. Throughout this webinar, we will hear from our experts who will shed light on the topics of tropical agriculture, tropical architecture, tropical engineering, tropical medicine, and tropical natural resources. We have an excellent lineup of speakers. who will share their expertise and insights on various topics on the tropical world. Allow me to introduce them one by one. The first speaker relating to tropical agriculture is Dr. Alexander Tilley. He's a senior scientist at the World Fish. I believe it is based in Penang, Malaysia. Our second speaker relating to tropical architecture, Dr. Architect Serena Hijaz, Principal Director at Hijaz Kasturi Associate Sdn Bhd. Our third speaker on tropical engineering, Professor Engineer Dr. Fatima Ibrahim, the head of the Center for Innovation in Medical Engineering of University of Malaya. Our fourth speaker, relating to tropical medicine, Dr. Georges Sinonono, Research Director at the French National Center for Scientific Research. And our last but not the least, our fifth speaker relating to tropical natural resources, and Professor Dr. Susan Page, Professor of Physical Geography from University of Leicester, UK. To our audience, our speakers will share their insights further through a question and answer session later, and we encourage active participation from the audience. So please feel free to ask questions during the Q&A session. You can submit your question to the chat feature or chat box, and we will address them as many as possible. Now, without much further ado, let me welcome our first speaker this morning, Dr. Alexander Tilley. And Dr. Tilley, we are delighted to have you with us today. And Dr. Tilley's presentation, his topic of his presentation is on the emerging technologies for food security and sustainable livelihoods in the tropics. So Dr. Tilley, the floor is yours now.
Thank you very much. And thank you for the opportunity to talk to you today. I believe you are controlling my presentation from there, so thank you. All right, I am going to reflect today on some of the opportunities presented by emerging technologies and digital innovations for small-scale food production in the tropics. Next slide, please. So much of the food production and agriculture in the tropics comes from small-scale farmers and fisherfolk. Yet the nature of these food systems at small scale, these local food systems, makes them very hard to monitor. So often we have very little information and resolution of who is producing what, where, when, and how much. Next slide, please. There are substantial challenges faced by small-scale actors in producing food to eat themselves and to sell for their own income. They are more vulnerable to shocks, so climate, weather shocks, but also health and social shocks than large-scale food producers. And they have very low political power. So when decisions are made, they often don't have a say in what happens to the resources they depend on. There are also substantial systemic barriers to their inclusion and their production, so such as access to education, access to technology, even power or electricity in places, and things that we take for granted, such as sort of identification with which to register for a bank account and access microcredit. All of these things are barriers to their inclusion and their continued sustainable livelihood. On top of this, we also have the rising costs of food from elsewhere, so imported food. And people that depend on natural resources are often in what's called a poverty trap, where they're depending on a declining resource. So they have limited options to get out of that and do something else because they're becoming increasingly poorer. Next slide, please. So all of these challenges are pervasive in my area of research. I work in what are called small-scale fisheries, and these are fisheries that are people in small boats. They might be motorized, they might be paddle canoes or wind-powered, or they might be people gleaning and fishing from the shore. They are basically small commercial and subsistence actors. And they are highly marginalized both geographically because they're, isolated in rural coastal areas, but also isolated due to infrastructure and support, and isolated from decision-making centers as well. It's said, a famous quote about fisheries is that managing fisheries is hard. It's like managing a forest, but the trees are invisible and they keep moving around. And the same is true for fishermen and women themselves. How do we effectively monitor their activities to generate information with which we can help to sustain their livelihoods and that really important food production? Next slide, please. So although they're small, they are mighty. And on a global scale, small-scale fisheries represent about 40% of the global fisheries catch. And this is inland and marine, so freshwater lakes and rivers as well as the seas. This is especially true for the tropics. The tropics represents, proportionally almost all of the small-scale fleet globally. In Asia, especially, it's over 80% of the global fleet. And in terms of numbers, this represents hundreds of millions of jobs, especially for women, in the sector in processing and in trade, and also represents food for billions of people and nutrition security. So these are, as I say, although they are small in scale, they are hugely important when scaled up globally. Next slide, please. So much of my research is based in Timor-Leste, which is a small island nation above Australia at the eastern end of the Indonesian archipelago. Here, almost nothing was known about the fisheries a few years ago when I arrived there as a postdoc. But fisheries feature quite highly in the national development objectives of the country, so we needed information about them. So using predominantly free or very cheap software and approaches, we set up a monitoring system where data collectors on beaches would chat with fishers and record their catch and submit it on a tablet. And then we could automate, we write a script, also in a free software environment, write a script that automated the analysis of those data and provided near real-time information on a dashboard, which you can see in the bottom right there. Next slide, please. So this is sort of a timeline that shows the iterative development of the dashboard and changes that were made in feedback with local stakeholders in Timor. And I'm sure you're thinking, well, so what? It's another dashboard. What can we do with that? It's just, boring data. But what this represents is currency for decision making. So that's what we consider information to be. We often take it for granted, but all of the decisions we make in our lives are based on information. And so now we know how much fish is produced, where it's produced, and when, what the kind of seasonality and the trends of that production is. But more than that, which is shown, but you probably can't see it in the final 2023 version of this, is with advances in nutritional analysis, we can now model what the nutrition supply from catches from small-scale fisheries in Timor is. Next slide, please. So in a place like Timor, this is hugely important. And I mentioned previously about national development objectives, but Timor has the third highest rate of childhood stunting in the world. Childhood stunting is micronutrient deficiency in diet, whereby you're not getting enough micronutrients like zinc, iron, calcium. Diets are energy rich rather than nutrient rich. So they're eating lots and lots of rice, but not really a diverse diet for brain development, bone and body function. So this information is hugely important in driving those national goals, in that now we are able to target intervention or utilize fisheries in a way that specifically eliminate malnutrition in the country. Next slide, please. So a fish is not just a fish, and now we know that we can see that different species of fish at different times of year in different areas have higher nutrient densities than others. Some are more abundant than others and at different times. And this information can be really used to maximize the potential of those fisheries at eliminating malnutrition. Even to the extent where if you have a specific micronutrient deficiency, you may be able to target fisheries and manage them less from a production point of view, in terms of we want to maximize production, but we want to maximize the nutritional security potential of those fisheries. Next slide, please. So when this scales globally, the potential nutrition supply from fisheries is substantial. We're talking hundreds of millions of people, and they're, contributing to their recommended daily intake of various micronutrients. And then consider that this is just from small-scale fisheries landings, but if countries start working towards nutrition-sensitive fisheries management, and keeping fisheries production for domestic consumption as opposed to selling it relatively cheaply as export, we could actually eliminate much of the malnutrition or undernutrition or micronutrient deficiencies in the tropics. Next slide, please. So one other element of this, stepping away from nutrition for a moment, is just also the value of this information and these data systems is in evidencing livelihoods. And so thinking about things like the blue economy, where different people have different needs or requirements over ocean space, let's say, and the same occurs on land. The map here shows Penang in Malaysia, where I am standing. And we piloted similar technology to track small-scale fisheries in Penang. And you can see here that it doesn't take very long. This project ran for a year or two, and to get a very detailed picture of where fishers are going, how much time they're spending, what areas are important, and this kind of evidencing in data for those fishers can be hugely beneficial, especially when there's kind of land reclamation or coastal development projects in which they might be kind of bulldozed over in terms of not having very much political power, but when they can illustrate their livelihoods in data, it really allows us to support their claims to access to resources and space. Next slide, please. So just in summary, it's important for us to utilize, cheap or free open source technologies to solve problems or highlight issues or tackle challenges in the tropics for small-scale food producers, because often there isn't the budget to develop complicated, contextualized, like bespoke apps and technologies, but there are many solutions out there. But care should also be taken that by doing this in a participatory and co-generating way, we can avoid reinforcing existing kind of power disparities by creating, let's say, an app that only people with phones or the money to buy it can access. So it's important that we bridge that digital divide, if you will, through our development of these apps. Thank you for your attention. Next slide, please. That's just my final one. Thank you for your attention. If you'd like more information, you can have a look at those sites there or drop me a line. Thanks.
Thank you very much, Dr. Tilly, for that enlightening presentation. And I think your insight have provided us with valuable knowledge on food security. And that thing that struck me about Timor-Leste relating to crocodiles, I will pose a question on that. And of course, I'm quite impressed with your slides on the intensity of fishing around Penang Island. And I think that would be relevant in considering this forthcoming project on reclamation, coastal reclamation. Yeah. Well, I'll come back to you on those two. Now, we will have we have to move on to our second speaker, Dr. Architect Serena Hijaz. She will enlighten us on the subject of ecology and architecture of the future. Dr. Serena, the floor is yours now. Yeah.
Thank you very much for the introduction. I'm really in awe of the previous speaker's message, and especially in terms of the data analytics that equate and give information to where we are. And I told the Dr. Alexander that I'm not showing a little bit of PSI here. We were involved in the concept stage. We're not involved anymore, but a lot of care was taken for the biodiversity component, but going forth, we'll see how that goes. My topic today on ecology and architecture, I guess, is just quite divergent in a way from where we've come from. And I started down this path because of the question of ecological footprint and the amount of resources we need and the biocapacity of our Earth, or in particular Malaysia as well, because we take for granted a lot of things. You know, we take a lot of granted that we get 12 hours of sunshine a day. We take for granted we have a lot of water, but there is an ultimate truth to where we are essentially. You know, in 1990, when I was sort of born, I can't tell you where that is in the circle there, we were basically, you know, we had a much larger biocapacity for the number of people that we have and the development that we had. And so we weren't too concerned with regards to how much we're developing, and of course the talk about our forests and how much capacity we have there apart from our land for agriculture. But at about 1993, we hit that zero line. In other words, we were not basically we are not actually producing this balance between our biocapacity and our ecological footprint. And we already passed that in 1993. And at the moment, we're really at this sort of deficit. You know, this statistics is 2018, and we're already at -2 in terms of our ecological footprint. And that just posed a lot of questions for how much we develop. Of course, we can't stop development, but it's really important how we look at how we develop, and trying to push this envelope that, maintaining this balance of above 50% in our forests, above 50% in terms of our urban greenery, and all the rest of it is very much important as we're hitting a lot of issues on the heat island. And so it's very hard to explain to anybody with regards to the total CO2 emissions. It's a very abstract component. Somebody in the city, or somebody even outside the city, of course, they outside the city don't actually create as much emissions and waste as those in the city. But having something, trying to visualize what the effects are happening to us, and this is, of course, from NASA on the CO2 volumetric, and it's interesting to see that a lot of it is on the northern hemisphere at the moment. Maybe because in the equatorial belt we still have a lot of greenery. Maybe a lot of it is also to do with the past. In other words, the emissions that come out are really from 20 to 30 years ago. And even through the pandemic, the CO2 levels didn't really drop that much because the effects are from the past catching up with us. And so when we're building in the equatorial, right at the beginning when we started doing buildings, culture and context is important. Daylight and glare. Our sense of daylight and glare in Malaysia is quite different from Northern Hemisphere. We are a little bit more sensitive to daylight and our glare. And so the capacity for us in terms of wanting to go out and sun ourselves is quite different. We'll probably prefer, like Sri Lanka, to take our umbrella out and walk out in the sun rather than actually get direct heat. But we see interesting things on temperature and heat island, humidity and air movement. We do have a lot higher humidities here. And to get that sense of comfort, we need a sort of minimum 1.2 meters per second just to feel a little bit more comfortable, whereas in the Northern Hemisphere is quite different. Rainfall is aplenty, but we're also seeing some droughts and floods. Mosquito and disease is part of that component, where Malaysians try to sort of pull away the landscape away from their buildings. But the other aspects that is creeping in is development and rising density, increase of waste and circularity, loss of biodiversity and ecology, and climate change and carbon. So when we're trying to respond to designing in the tropics, whether it's outside the cities or in the cities, these are the things that are now creeping into the consideration. We say at health and well-being, these are the components that we really should consider when we're designing. And this relates very much so to the planetary health in terms of, and what really hits us in Malaysia in terms of humidity, the rapid rise in global heat stress, the temperature rising, and we'll talk about that in a little bit in terms of, again, coming back to Penang and showing that we've already have a 1.5 degree islands tend to pick up on the change a lot more than we do. Water, biodiversity, the ocean pH 30 degrees, the air increase, and the CO2, and it does make us think about how we're going to build for the future and what we need to consider. So we have a couple of studies that have been done, not by ourselves, but in Malaysia, by Think City, showing the heat vulnerability, heat indexes for major cities. And you can see quite clearly, of course, densification because of a population growth is basically causing quite a lot of heat stresses. And whilst we talk a lot about flooding, our vulnerability to flood. One of the biggest issues for us is actually heat vulnerability. And the mean temperature of 1.5 degrees has already been measured in Bayan La Paz. So urban greenery is really, really important. And I guess that quite a strong proponent in thinking about how we still include ecology and urban greenery into all our developments going forward. And this balance of energy, resources, and ecologies is really an important aspect to restore this imbalance that we are having. And so maybe some of you are familiar about the sort of net zero pathways that everybody's talking about. Big corporations are talking about, 2030 and 2050. When we are building, I think that we really should be looking a lot more closer to nature-based solutions. We can start with passive designs from the offset. That's to optimize shading and cross ventilation and aspects of insulation at the first level, at what we call the first approach that we take in our design. And then we think about the active systems of how we want to cool the building. Then we have to think about the energy efficient cooling or hybrid systems, renewable energy, of course, and then carbon offsets as the last mile. And in fact, we're developing with Malaysian Green Building Council at the moment the carbon score, where we are really not considering sequestration and carbon offsets, because really this is the last mile, and this is really not going to make the main difference. The main difference is in 1, 2, 3, and 4 when we want to look at advancing net zero. And why it's important is to get down the greenhouse gas that is affecting the climate change that we are in. So climate adaptive and nature-based solutions is increasingly looked as a sort of solution in the built environment, and with the adoption of ecology and biodiversity. Hence why you see an island like Singapore essentially promoting themselves as a nature and increasing their ecology and biodiversity by planting on roofs and things like that, if they're not providing the solar as a sort of balance to cool down the environment of the city that is overheating. And so I just wanted to show you some projects where this approach is seen quite a bit, projects that we have been involved in. This is the Kasturi. We call it Embraced by Land and Sea because, of course, we're facing the sea, but we also try to maintain as much of the mangrove on the site. So you can see that this is the entire site that we've developed. And this is a sea frontage. And just to show you that in the 5 years that we have built this resort, we've had to build a rock embankment in front because we're getting a lot of erosion. And the water levels are actually coming right up to the building front. So we've done the setback that is required by the DOE, all the rest of it. We've raised the platforms. So for moving forward, we're seeing that coastal lines developments have to build in the climate change of 1.5 degrees by building their platform levels higher, because we do know that that's emerging as an issue in the tropical belt. But water for this building was coming right up to the building itself in the monsoon, and we had to create this breakwater embankment line that we naturally put in, and that protected, and we extended it over. It actually protected the erosion from the front. So whilst we have the mangrove and a little bit of the green, we are still seeing these effects. And this development was that we tried to maintain that we have more than 60% of the natural environment around us. And the benefits of that is that we see about 3 to 5 degrees in temperature under the trees. We obviously have the carbon sequestration of the mangroves surrounding us. But you will see that a lot of it is that we've provided such a shading around our buildings to the environment itself. So you don't see the connecting pathways that connect to the buildings. It's all hidden. We actually have a couple of other units underneath the tree canopies over here. So more than half of the buildings, even in the front, are actually covered by the landscape. Here's just showing you that, you know, the canopies are actually shading the buildings, but we're trying to maintain as much of the ecology of the site without affecting too much. And measurements like this are now starting to come into play in terms of looking at how much footprint we take on the site, how much indigenous natural species we try to maintain or grow if you're in a site that isn't, and how much of passive design is maintained on this building. So the buildings itself don't tell you that, but, you know, obviously we take sort of measurements of this just to give us a feel. And it's really quite important when we're building, of course, is to have the materiality and the context blend in together and use as much of natural material from the site. This is not always possible to that kind of level. And as we get bigger and bigger in the projects, how do we still adopt this kind of approach to the design? This is Cahaya Langkawi. It's a new hotel that's coming up in Langkawi. Interesting that there is a sewage release, water release that came in prior to us looking at the site. And this is basically being looked at in terms of a nature-based solution to filter the water before it releases out to sea. So this is not actually to do with our development. It's actually coming from inland, but Langkawi is already starting to look at some of these and propose nature-based solutions of filtration coming here before it actually releases out. So we're around this little hill outcrop, which is actually a private land, but we have a very short frontage in front, and we sort of curl around the hill as much as possible and try to maintain as much of greenery around us and a much smaller print. You know, this building was initially going up to 15 stories. It's now coming down to what I would say that waterfront developments need to really be sensitive to by bringing down the scale of the buildings. This is about 10 or 11, but you'll see that the responses to this is the earlier one. The nature-based solution is at work at the moment. So we'll start to change how this actually will look a little bit softer in terms of the filtration. But the orientation and building facade takes from our culture and context in addressing glare and daylight. So we have abundance of light. I always call that the natural energy. We are very lucky to have abundant light, but we don't know how, from the traditional ways, on how to control that sort of glare and daylight that comes into our space. So we've looked at the development of the facades surrounding the building by creating these sort of traditional elements on the building to shade the building. And orientation is very important. So when we talk about passive design in the tropics, the north-south elevations, we try to maintain a much more longitudinal format in terms of the planning if we can. And the east and west is really where we need to control the heat gain coming into the buildings. And the difference is really quite high. In a typical building that we had done before, the OTTV, which is what we call the overall thermal transfer coming in from the east and west, is about 40% higher. And therefore, orientation is really, really important if you can help it in your buildings. And a lot of it is, of course, it's fortunate. It's a resort, so natural ventilation. What needs to be taken care quite a lot in these kind of environments is the rainwater. As soon as we get cross ventilation between two sides, rain penetrates as much as 40 to 60 degrees into the center of buildings because of optimizing on cross ventilation. So these are some of the responses that I haven't quite explained here, but just to give an example. Affordable housing and densification issues in Penang seem, not only Penang, but Kuala Lumpur as well, as we are expanding in terms of population. How can we humanize these sort of affordable housing? And Kuala Lumpur is suffering just as much as Penang, where we're seeing buildings that are about 40 stories high, and it's with very little shading and insulation to the facade. But the move here is, how do we get densification and still approach to designing in a tropical environment? So urban housing typologies, typically this is what we're seeing. We're seeing podiums of car parks, and it's quite scary to see some of the developments at the density where you're having 3,000 homes in Kuala Lumpur going up. And so how do we still try to get the density, but humanize some of the responses? We've grown from 70 units per acre to 148 units to 173, moving up to 43 and 48 stories and 49 stories. So we know we need to approach density in the cities, but how can we actually make it feel like you're living in a shorter dwelling that is more to scale to the ground? So we took this as a sort of study. It was a competition and it was an ideas one. And these were the elements that we wanted to look at: bring the scale closer to the ground, introduce neighborhood pockets vertically, give community and nature-based spaces like markets, bike parking, rooftop agriculture, provide shaded streets and marketplaces that you sort of feel that you find in the cities like Spain and Barcelona, but we don't find that in our tropical cities response. And so creating a tropical response in terms of the roof and shading and the building, but giving you that density of 153 acres, 153 units per acre, but an 11-story building as approached to a 30-story building, which gives a much better response to the habitats inside. Probably one of the better examples and early examples that were done, this was by Moshi Safdi and Habitat 67. We saw this as a sort of compelling way of bringing urban greenery up to the building and providing sort of habitable spaces that feel a little bit more humanistic in terms of scale. But it doesn't respond well to the tropics. We really need the big roof. We really need to shade our streets. So turning that upside down and having the angles of the buildings as self-shading, so inhabitants feel self-shaded in the buildings, provide 15 to 25 degrees in slope, basically gives you this self-shading in the tropics. Providing rainwater collection, urban farming opportunities on a very big roof, creating the sort of different diversities of opening inside the spaces, just gives you a far better spatial planning and humanistic approach to densification and bringing us closer and optimizing in terms of providing still urban greenery around our site. So these were some of the ideas that we've been developing and looking at, how we respond to what is coming in terms of climate change. And lastly, this word of advancing net zero carbon and net zero energy. Malaysia basically went to Expo. I know Expo is seen as not the most sustainable. However, Dubai Expo actually provided a very, very succinct, sustainable requirement in terms of the building. But when we decided to build there, not only were we looking at materials that are more bio materials, but we were looking at what happens after the building, that 75% of the building materials could be recycled. We are part of a legacy, so we were one of the very few pavilions that have maintained there for the next 5 years, but that the overall master plan for the Dubai Expo is now turning into a residential and housing area. So the concept for this rainforest canopy and touching the ground lightly was to show that Malaysia could basically try to see how we could actually approach a net zero carbon and a low carbon pathway when we're building. It's very unusual to build temporary structures, when we're given the site, it's basically ground zero. And when we have to complete the building, we have to return the same earth that we took back into the site. So you're thinking on how to build different.
I'm sorry, Doctor, we have 1 minute left.
Yes, not a problem. I'm just going to rush through in terms of the components of building something that is a net zero and giving you an idea what it takes. This was all a timber structure. It's a hybrid structure, timber and steel, but all the materials, 75% of it in terms of the embodied energy of the building was calculated in terms of how much energy to build this building, but how much to take it down and how much could be in the circularity of building materials. And so it's the way of the future that we're actually going to start thinking about how extensive materials that we're using. And what came out of this really was not so much in terms of the measurements, but in terms of the approach and thinking of how we're going to build for the future. We're not just thinking about operational energies, but we're thinking about embodied energies, building materials, and this discussion about growing our cities from biomaterials like trees, but growing trees sustainably for growing our cities has started to take afloat. I think that the pandemic taught us quite a lot of things, but I really liked what Richard Attenborough had said, that the single most used space in these times has been the need for expansion of open space and proximity to nature. And it's the only thing that has kept us sane and will keep us sane, and therefore the importance of this balance of ecology into any one of our developments. Thank you.
Thank you very much, Dr. Sarina, for that insightful and excellent presentation with impressive visual and infographics. Yeah, I wish we had more time for you, but very unfortunate we have to move on. Now, we hope to. Now, I would like I have the honor and pleasure to invite Professor Engineer Dr. Fatimah Ibrahim to speak on the point of care medical devices. The key to early detection and treatment of tropical diseases. Prof. Fatimah, you have the floor.
Okay, thank you very much, Dato. Let me allow me to share my screen. Can you see my screen?
Yes, yes.
Okay. Assalamualaikum warahmatullahi wabarakatuh. Thank you very much. And today I would like to share my research on the point of care medical device, the key to early detection and treatment of tropical diseases. And this is the presentation outline. So I will be introducing about what is the neglected tropical diseases that many of us are not aware, and then sharing with you the point of care medical device that we have been doing in our Center for Innovation Medical Engineering in University of Malaysia, and summary and also the challenges. So basically, what actually is the neglected tropical disease? There are groups of 20 infections that are prevalent in the tropic, affecting 1 billion people according to WHO. And these are caused by the variety of pathogens, including the viruses, bacteria, parasites, fungi, and also toxin. And in Malaysia, the most prevalent, as you know, there is the dengue infection and also chikungunya. So if you look at on the right side of my slide, there is a figure of the graph showing that the dengue cases up to today, 36,997 cases, and it have increased about 185%. And at the week of 17, a total of 22 deaths due to the dengue, as compared to 7 deaths in 2022. It shows that dengue infection is still the prevalence infectious diseases, tropical disease in Malaysia. And it is very important to have an early, low cost and point of care detection of these tropical diseases, importantly to save the life. So what actually is the point of care medical device? So point of care medical device actually are used by the healthcare professional to perform any kind of disease analysis, diagnosis, monitoring close or near to the patient bed and obtain the result instantaneously. You can see that the sample can be the saliva, the urine and the blood, and the medium of the detection can be, the point of care can be in the transportable, disposable, portable, handheld, rapid, and benchtop. And I would like to share you a little bit, allow me to share with you a little bit about my center, because our Center for Innovation in Medical Engineering consists of all the engineers and also the members of Faculty of Medicine, the medical doctor in University of Malaya Medical Center. And our objective actually is to innovate any medical device to solve the problems and try to commercialize it. So these are a few of the medical devices that have been developed in the Center for Innovation Medical Engineering. We have developed the dengue biosensor. We are in the process of developing the sepsis detection kits. And we have already developed the food pathogen, especially detecting the Salmonella lab-on-chip. So before I go further, I would like to introduce a little bit about the technology. So there are two, the technology we are using actually is a new innovative technology. We call it a microfluidic platform. So what actually is a microfluidic? Microfluidic actually deal with a small volume of liquid, typically in a microliter range of sample. And there are two types of microfluidic. One is lab-on-chip. So when we say lab-on-chip, it's something like a piece of material, and you need require an external pump to move the liquid into the platform. However, we have lab-on-compact disc or centrifugal microfluidic, which spinning. This microfluidic utilize the spinning process to move the liquid inside the platform. So you have one is the stationary one, another one is that the CD is spinning. So why we want to introduce this technology? So I would like to share with you, these are the new innovative technology for the future for the medical device. Looking at the left side, this is the conventional laboratory whereby you need to have a very big spaces, you need to have your test tube, your all these incubator and all other things. But the future lab is that you can miniaturize the big spaces of your lab and whatever the processes of the chemical into mixing or centrifuge wherever can be transformed into the lab-on-chip. So everything, your test tube, everything can be done on the lab-on-chip. So this is, for example, the reservoir, this is the channel and everything. So in future, what we are going to do is just to drop our blood on top of the lab-on-chip and let it do all the processing and using our handphones or any kind of display and get the result instantaneously. So these are the new innovation that we are doing. So these are the innovation that we have done for the lab on chip. So we are focusing on the platform on the biosensor. So in terms of the biosensor, we have two types. One is the 2D, another one is the 3D. So let me share with you the biosensor that we did for the 2D. So for the 2D, we are using the silicon chip, and then we coated it with some polymer. And what we have done is that to use the conventional ELISA and put our biosensor in the microtiter. These are just for to enhance the detection. Something like you're cooking. When you cook something, you want to enhance the flavor. You will put Ajinomoto in Malaysia. I think Malaysia is famous in putting this additional flavor, so enhancer. So for our medical device also, we have our enhancer. So this is our enhancer, the biochip. So when we put this biochip, it shows that according to the conventional result of the microtiter ELISA, it can enhance the detection 10 times higher than the conventional. So these are the things that we want to do. And on top of the silicon is a little bit expensive. So what we have innovated is using a paper base, and we coated our polymer into the nylon membrane, and the reaction and the detection is also 10 times. So in terms of commercialization, you can see the cost effective. If you have more budget, then you can use for silicon, but we'll go for the paper base that is cheaper. And the 3D, so these are the 3D that we are working together with our collaborator with Holland. And these are the 3D biosensor, whereby it's only about 600 or 700 micrometer, and we coated with our polymer recipe. And then at the same time, we put in our lab on compact disc, and it enhanced the detection not only to 10%, but 20% higher from the detection signal. You can see that the accuracy is about 94%, the specificity is about 87% as compared to the ELISA that's only giving you 81 to 76. And if you want to know further, this innovation has been published in Nature Scientific report. And these are the future dengue diagnosis that you are going to do. You are going to see in future, led on compact disc with the ELISA reader. So our objective actually to combine of this biosensor with the 2D or the 3D to make it higher detection to 10 or 20 times. And the novelty is to have a low cost. If we do it in mass production, we can be able to have it in like less than $1 USD. In a mass production. So these are the nylon membrane. If you can see that in the nylon membrane, we have done the testing in the University Malaya Medical Center, the WHO Herbovirus Center. We have shown that the conventional ELISA can be able to detect the dengue, the limit of detection. You need about 1,000 dengue virus or 10,000 dengue virus only can be detected. However, our innovation for the low cost biosensor only need 117 viruses to be positive. So these are the things that we want to enhance to have early detections, at the same time can have low cost to reduce the cost. So previously we have discussed about the biochip sensor. Now I would like to bring you to the new innovation that we have done, the novel thing that we have done. We already have transformed the conventional ELISA at the laboratory into our compact disc. So when we say about compact disc, I don't know whether you can see my picture here or not. I'm sharing with you. This is the disc that we have. So these are the discs. So in this disc, the novelty of this disc actually is the design inside the disc, the design for each of the application. So we have designed this, the conventional ELISA, exactly whatever ELISA has been done in the lab has been transformed into the lab compact disc. The advantages is that we have reduced the sample size. If the conventional need about 150 microliter blood, but the one that our innovation is only, you need only to have draw blood about 10 microliter. So how does it work? We have this the detection chamber. This is the waste chamber. And when the CD is spinning, they will do all the automatically processes whatever the chemistry of your washing, stopping and so on. So I'm not sure whether we have the time, but this is the video that we can be able to capture during the process, the proof of concept of our innovation. So you can see that this is our detection chamber. This is spinning very fast. Now it's doing the incubation positive. It is doing the flushing out. It's flushing out, incubate with the dengue conjugate antigen, and incubate for 60 minutes, and then wash it, and then having the stopping solution. And there is a, at the end of the day, you can see that there is a colorimetric changes, and you can have the reader to read whether it's positive dengue or not. So this has reduced the detection time from 3 days or 1 day into only 2 hours. These are the one that we already put in that. Okay, so previously when I talk about this is a label base whereby you already coated the detection with the antibody. But these are the new one that we are introducing, a label free, whereby you do not have to have any antibody. You can just take the full blood and drop it into our lab on chip using the technology of, we call it dielectrophoresis, DEP, whereby in our normal blood, if you can see that this is normal blood, if you have a dielectrophoresis electric dielectric particle crossing over here, you can see that there is a positive DEP or negative DEP. However, if your blood has been contaminated with some viruses, like example for dengue, then your blood has a different frequency. So from here, we have done the experiment, which shows that the blood affected with dengue is about 140 kilohertz. The normal cells is about 220 kilohertz, means that you can be able to differentiate the blood with the infected with dengue using this biochip. So this is more faster. You don't need to have any incubation and so on. It's less than 30 minutes. You can be able to diagnose whether they are positive dengue or not. So these are the optical reader. At the same time, not only we innovate the sensor, but we also develop the instrumentation, the medical device, whereby when the reader is already, the CD already spinning, it stops and there is a reader to display. So we mimic this one as the conventional microplate reader. As you know that the microplate reader at this moment is very expensive. It depends on where it is from. So the one, it costs about 150,000 and more than that, but the one that we innovate is less than 2,000 below. So these are the low cost that we really need to innovate so that it can be affordable to all over the country in the tropical. And we have done this test at the University Malaya Medical Center, and the sensitivity is about 95% sensitivity and 100% specificity. And this is another dengue monitoring. So previously that one is on blood investigation. Now we are looking at the clinical management, whereby we can be able to monitor whether the dengue patient is risk to bleeding or not bleeding based on their platelet count, 200,000, liver function test, and also their hematocrit, whether it's 20% above. So when we did the experiment, we compare with that blood investigation, and we can be able to get that parameter inside our bioimpedance, and in future, the bioimpedance can be able to do the risk prognosis without taking the blood anymore. And it's very fast. You can just put electrodes, and then with a few minutes, 1 minute, you can be able to know whether this patient has been risk or not risk of bleeding. And this is the video. So I'm not sure whether we have time. Maybe if we have time, we can show the video. So okay, so these are the another for dengue application, whereby we are using artificial intelligence. So these are actually the request by the medical doctor. So when I did my PhD previously in that, the doctor asked me, hey, can you be able to detect for the dengue patient when these patients are going to have no more fever? Because I asked her, why you want to detect when people have no more fever? So for conventional infectious diseases, if you have no more fever, you are recovering. However, it is opposite for dengue patient. For the dengue patient, if you are going to have fever, these are the things that you are critical, that you are going to have hemorrhagic. So then the doctor asked me to develop a kind of a device or whatever software that can be able to predict the effervescence of fever. So we already successful predicted the effervescence of fever with only the symptoms of the patient. So you can read more. This one has been published in the Journal of MBAC. salvia. So enough about the dengue. So now we want to look into other tropical diseases such as the foodborne pathogen. So the foodborne pathogen that we are looking are Salmonella. So Salmonella at the moment now, the conventional one is using the LAMP technology, and it takes hours. If you go to the restaurants, means that the conventional one, the Majlis Bandaran Daerah, will take the sample and then bring back. It takes 1 day or 2 days to diagnose whether the food has been contaminated or not. At that time, the restaurant, the people already have diarrhea and so on. But our devices that we can bring this device to the restaurant and do detection at point of care instantaneously, can get the result within 1 hour, 2 hours, to say that this food has been contaminated with Salmonella or not within that. And we can close the restaurant instantaneously and avoid many people to get all this infection. So these are the technology that we want to have a point of care at the moment. And these are the innovations. So the innovation have many. One, we are doing on the lab on compact disc, and we are also looking at lab on chip. So these are the lab on chip. Is more preferable because you don't have to have a spinning. You just inflate the food inside, and it can be able to detect whether got a Salmonella or not. And the limit of detection is very, very good, 10 CPU to detect, and it's less than 20 minutes as compared to the conventional PCR, which is very expensive and takes time about 3 days. And last that we are doing is the latest one. I would like to thank MOSTI for giving us the trust and opportunity to do the sepsis project. So these are our baby project now we are doing, and hopefully it will be realized soon. So this our device can detect the sepsis biomarker and sepsis causing the pathogen parallelly using the electrochemical detection. The sample processing is done on the chip. So this is our chip, is something like a cartridge. You put the sample of the blood, and inside the cartridge using the digital microfluidic. So these are the pre-processing that we do, the digital microfluidic, that the fluid can be controlled to whatever the movement that we want to control it, to do the mixing, processing, whatsoever, and inside this one. And then using the electrowetting on the electric principle. So once we already put the blood, the device can be able to detect whether this blood is being contaminated with virus, bacteria, or fungus. So these are the innovation. It will help a lot for the medical doctors to diagnose and give medication and a proper treatment for this dengue, for this sepsis patient. So summary, point of medical device, I think is very, very important, especially for the neglected tropical disease, because with this innovation, it can give rapid, quantitatively and accurate diagnosis, low cost for result limited setting, and enabling early and timely treatment intervention. And it's also good for control of disease transmission. But the challenge is that to do the pre-sample preparation, the signal amplification, the methods, and the multiplexing capability. And lastly, the challenge, I think that from my experience, that to have come up with the new innovative techniques and commercializing the medical device safety compliant test, and also getting it to register in the medical device authority in Malaysia. So if we can be able to have this, we can be able 70% of the decision of this based on point of care improve the medical outcome. We can also save 20% of the laboratory cost, and we can also decrease the waiting costs. And according to the Abbott laboratories, the waiting cost per patient is about 260 USD. With that, I would like also to thank to all my PhD students and my research officer, and also my research fellow who have already contributed to the research to become this research to be realized. And for your information, the dengue nylon membrane coated, we are in the process of negotiation with the UK company that owns the Bill Gates and Melinda Gates. They are interested to license this innovation to have a low-cost biosensor for the tropical diseases. With that, I end my presentation. Thank you very much.
Thank you very much, Prof. Fatima. We're all looking forward to this rapid adoption of your rapid test. I think that will be of great help in terms of solving a lot of our problems in the tropics. Okay, our next speaker, we are behind time, but anyway, we'll catch up. Our next speaker is Professor Dr. Georges Sinonu. He will speak on his expertise of tropical medicine entitled The First Malaria Vaccine, RTSS Mosquirix, of Smoke and Mirrors. Dr. Sinonu, the floor is yours.
Thank you very much. Thank you for inviting me to give this presentation to you. I'll try to catch up on the time. If I can have the first slide, please. Okay. Right. Now, so what I would like to talk to you about is more of a cautionary tale, and is to present to you the first malaria vaccine. Next slide, please. I just very quickly present to you the malaria life cycle. As you know, it's a mosquito that bites you, injects a parasite called the form called the sporozoite, and this goes to the liver, and from the liver it amplifies, and then it infects red blood cells. These red blood cells, the parasite grows cyclically, which gives you the disease, and then eventually a mosquito will pick up some parasites and complete the cycle. Now, people have been trying to do a malaria vaccine since the 1970s, and only in 2020 was the first malaria vaccine presented by the WHO. Next slide, please. And that vaccine was attacking the sporozoite, specifically that part of the life cycle where the mosquito infects a human. Now, the idea of a sporozoite vaccine started from the 1910s, mainly, and then with a little bit of work in the 1940s, but it's only in the 1960s that they worked out that if you have an attenuated sporozoite and you inoculate it into a host, then you can get protection, first demonstrated in mice, and then in the 1970s demonstrated in humans by infecting them with irradiated sporozoites. This started this quest for this malaria vaccine. Next slide, please. Now, this is what the sporozoite looks like when you put it in naive serum. It's perfectly normal, it's perfectly healthy, it looks like a little comma. And if you do, if the person has been subjected to irradiated sporozoites in its serum, and you take the serum from that person, so it's an immune serum, then the sporozoite sheds its coat. Now, the coat of the sporozoite, it was discovered in the 1970s that it consisted of a single protein called the circumsporozoite protein. And in 1983, this sporozoite protein was sequenced. And this is what it looks like: an N-terminus, a C-terminus, with a repeat region in the middle of 4 amino acids that repeat 20, 30, 40 times, depending on the strain of the parasite. And it is that protein that has been used to create a vaccine. And the first effective vaccine that was tested in phase 2 trials was called RTSS for the repeat TH region, and this consisted of this part of the protein, as you can see here, associated in a particle with an hepatitis S antigen. And this is injected. And in 1997, the first trial was done in naive volunteers that were experimentally infected. Next slide, please. Now, in the first trial that was made, 6 out of 7 volunteers were protected completely from infection. Therefore, the mosquitoes bit them, but no infection developed at all in the blood. However, one of the things that was important is that they tried 3 different adjuvants, and it's only with one specific adjuvant that this worked. With the other adjuvants, they had very little protection. Nonetheless, this encouraged everybody to go and try it into the fields. And in 2001 and 2004, I will present to you the data in a second. This was tried in Africa in an endemic setting. Unfortunately, the protection was not sterile. People did get infected, but they did get some positive results. And they continued these trials between 2005 2020 over hundreds of thousands of people in various parts of Africa, still not obtaining sterile protection. But nonetheless, in 2020, the RTSS vaccine was recommended by the WHO. Now, I would like just to compare that it was from 1997, when the first trial took place, until 2020. This is kind of 23 years in development. Just compare that with the COVID vaccine that occurred within about not in about 13 months, 12 months before it was started to be given. So if the emergency is strong enough, people will develop things much faster. Nonetheless, next slide, please. What I would like to share with you is my concern I have with this malaria vaccine. Now, the first trial was done in the Gambia in semi-immune adults. And this is the Kaplan-Meier curves of those people who are controls. This is the number of people who are getting infected. With time, more and more people are getting infected. These are in weeks. This is the number of infections in people who had the vaccine, the trial. So as you can see, they had an overall 34 protection. And this was measured as the time to get your first parasites in the blood. You will also notice that what happened here is that although it was effective over the first 3 months, by the time towards the end, it was finished. So effectiveness was about 70% in that portion, but by the time it the study finished, it dropped down to 34%. So the vaccine was protecting for 2 or 3 months only, and then the effectiveness was fading. Another trial was conducted in Mozambique, this time in children, which is the target population for these vaccination. And in this case, they did shift the endpoint to time to the first clinical episodes. And in this case, they got 30% protection, which is a barely sufficient to make it an interesting vaccine, but nonetheless. I can't understand how they calculated the 45% protection for time to first parasitemia like this one, because as you can see, by the end of the study, which was about 6 months, nearly everybody controls and vaccinated were also infected, has become infected. There was a slight delay in the vaccinated, but effectively, this was really non-significant by the time the study was finished. Next slide, please. Now, the question is RTSS truly effective, or is it only statistically effective? Because I have to say that if one reads all these articles, how they calculated effectiveness changes from article to a certain extent. And it is very difficult to kind of derive from it the exact effectiveness as one would see. You get vaccinated and then you get protected from illness. The correct measure, that is the one measure that we are confident with, is that if you follow the people over a long time, then you do reduce the number of clinical cases recorded over that time by 40%. Now, I would like to remind you that this 40% is nearly, in the majority of cases, to do with the first 3 or 4 months after the vaccine or after each boost. It does require 3 to 4 doses over 15 months, which is not easy for vaccination. Duration of protection is limited. This is why it needs so many doses. And in all cases, it does not prevent infections. Whether you're vaccinated or not, you still are likely to get infected. The severity that is being presented is reduced by 30%, is statistically estimated and not really based on a solid, how shall I say, statistically convincing measurements. Although if you play around with the statistics, you get down to 30% reduction. Next slide, please. Now, we thought we had the view in the beginning, we had a view in the beginning that maybe it is the adjuvant itself which is very important. And quite interestingly and disappointingly, in none of the trials that were made was the placebo that was used in the controls consisted of the adjuvant alone or the adjuvant with a non-relevant protein. That means something else than the CS and the hepatitis S antigen. And we thought that these adjuvants that they've used, they're called from GSK, are particularly powerful at inducing inflammation in the host. And it is well known that the parasite, when it goes to the liver, while in the liver, it is very, very sensitive to inflammatory responses. So we proposed in 2005 that maybe the reason why you get a protection very early on, but not later on, is because you have a combination of adjuvant-induced responses and anti-circumsporozoite responses. But it is also possible that the adjuvant-induced responses are so strong that one doesn't need the anti-CSP response. And we are now hoping to try to convince the community to try to use that vaccine alone as an adjuvant alone, because in which case it will reduce the cost of vaccine by quite a lot. As it is, it's quite expensive to produce these vaccines. And even the GSK who produced this vaccine can only produce about 18 to 20 million doses per year. And this is really hardly sufficient for to immunize children in Africa. Next slide, please. Recently, a new vaccine has appeared based on exactly the same protein, on exactly the same region with minor modifications, with an even more powerful adjuvant. And as you can see, this is timed to first clinical trials. They claim 80% protection over a 2-year period with 1 boost. But I would like you to have a look at what happens. This is for the first year. As you can see, for the first 2 to 3 months, you do have immunity, if you can see up to maybe 150, you still have an effect in vaccination, and then it plateaus. Now, the plateau is because in that particular area, there was no more transmission of malaria. It was the dry season in Burkina Faso, and therefore there was no transition. But when they reboosted, the effect was, to my vision, it was non-effective. And I've drawn here the slopes of the curves. Can you please push the next slide to see the... If you look at the first vaccine, these are the slopes for the controls, and this is how fast the cumulative index goes. And therefore you can see this effect, which is about 70%. Now, when you come back and look at it afterwards, after the boost, well, the slopes look very similar. Therefore, we don't really know why the boost was ineffective. And in a sense, this vaccine worked for the first 150 days, and on boosting, there was no boosting effect. So this is, I've finished my next slide, please. Unfortunately, an effective malaria vaccine is still a long, long way away. And one has to be very, very careful when you read about new vaccines to actually work out how people have calculated efficacy and whether that efficacy is sufficient to make it a good vaccine to deploy in endemic areas. I would like to thank you with this.
Thank you very much, Dr. Senono, for your insightful presentation and also for sharing your latest finding. And now it is time to hear our last but not the least speaker, Professor Dr. Susan Page, who will share her expertise on the importance of tropical peatlands and directions for responsible management. I believe she's not online. I think we have her recording, right? Yeah. Will you display her recording? Thank you.
Hello, everybody. Thank you very much for inviting me to speak to this meeting. And I apologise that I can't be with you in person or that I can't be with you online whilst your meeting is taking place. I've been asked to speak about tropical peatlands and their importance at the present time, which I will do. And then I'd also like to finish with some brief words about how I think we should be managing our tropical peatlands. So I'll talk about peatland ecosystems, values and services, where we see conflicts in peatland values, and some possible approaches to management. Well, as I'm sure you're aware, peatlands are an important part of the range of ecosystems that we have in Southeast Asia, but of course they're globally distributed and they have their largest extent in the Northern Hemisphere. Despite that, we are finding new information all the time about the extent of peatlands in the tropics. And so this is an exciting area that's still developing. And of course, peatlands are able to provide a wide range of ecosystem services, whether it's regulating services relating to water supply and water quality or climate regulation. They're also important in terms of supporting biodiversity. But on that diagram, you'll also see in the top left quadrant that peatlands are also important for provisioning services, providing food, fibre, fuel, and so on. And this is where the conflicts in peatland management arise. So then perhaps at the present time, given the importance of climate regulation, the most important role that peatlands play at the present time is in terms of carbon sequestration and storage. And they store something like 650 billion tonnes of carbon. That's all peatlands around the world, of which tropical peatlands, which are mostly focused on Southeast Asian region and in the Congo Basin in Africa, store about 100 billion tonnes. But 650 billion tonnes of carbon is more than the carbon in all the vegetation of the world. It certainly greatly exceeds our known oil reserves. So it's a very sizable terrestrial carbon pool. And in addition, functioning peatlands are one of the most important natural carbon storage systems that we know of. They're able to sequester atmospheric carbon dioxide, and of course the waterlogged conditions under which peat forms prevents the plant material from fully decomposing and therefore allows the accumulation of carbon-rich peat over many thousands of years. So in a natural condition, peatlands have a net cooling effect on climate. In addition, peatlands, and in particular tropical peatlands, support a rich biodiversity, a number of habitat endemic species, specialist life forms and strategies, such as the insectivorous plants. And because the peat swamp forests have not been as intensively studied as some other lowland dryland forests, we're still discovering new species. And that diversity extends to habitat diversity. So a whole range of different types of forests found on peatlands around the tropics, from South America and Central America through to the Congo Basin and Southeast Asia. But as I mentioned at the start, we often see that the critical peatland climate services are being threatened by lowering of water tables, which alters the balance between peat accumulation and decomposition. So if we want to grow crops, for example, food crops on our peatlands, most of these are dryland species, so they require a lower water level. And as soon as you drain your peatland, then you compromise the climate services that those peatlands can provide. So drained peatlands are subject to loss of stored carbon, loss of biodiversity. They're a very strong source of greenhouse gas emissions. In addition, we know that when we drain peatlands, and that loss of peat material as it decomposes leads to land subsidence, loss of soil, and ultimately loss of agricultural production. There's also a greatly enhanced risk of fire with all the attendant negative impacts that brings with it. Greenhouse gas emissions from peatlands across the world, those peatlands that have been drained for agriculture or for forestry, probably account for about 4% of total global anthropogenic emissions, and that's excluding fire. If we bring in fire, the number may be 5–6%. So in a disturbed condition, peatlands have a net warming effect on climate. And I mentioned fire. Here we see the hotspots of fire occurrence on peatlands during the strong 2015 El Nino event, and you can see that an area of particular concern is the Southeast Asian region. So how can we square this circle? How can we try to bring together the services that peatlands can provide for people in terms of food production and the services that they can provide in times of climate security? Well, this is a really big challenge. About 15% of global peatlands are used for some form of drained land use, whether that's agriculture or forestry. And in Southeast Asia, about 50% of peatlands at least have been drained for agricultural uses, and more than 70% have been deforested. So take away the forest cover, you lose your carbon sequestration machinery, and of course drainage leads to rapid loss of carbon to the atmosphere from the decomposing peat. Cropland hotspots on peatlands around the world. you can see that for agricultural use of peatlands, the northwest of Europe and Southeast Asia are hotspots. So these are also hotspots, of course, for emissions from that agriculture, emissions of greenhouse gases to the atmosphere, because all of this agriculture requires drainage. And a study in 2016 by Kim Carlson focused on the greenhouse gas emissions from crop production around the world. And she summarized that peatlands drained, particularly in Europe and Southeast Asia, account for something like 32% of the greenhouse gas emissions from crop production. And yet those peatlands are only producing around 1% of total global crop kilocalories. So this may not be a very efficient use of ecosystems that could be playing a much more important and vital role in climate security. Nevertheless, crop production on peatlands supports livelihoods. So, for example, in Southeast Asia, a kind of back of the envelope calculation is that possibly around 1 million jobs depend on oil palm production on peat. So there's clearly an economic and livelihood incentive to maintain that production. And it's much the same in other parts of the world as well. So we have extensive horticultural production on peatlands in the east of England. And again, very large numbers of people are employed in agriculture in that region, and agriculture is an important revenue source as well for that region. It also addresses UK food security. So what can we do to bring about more responsible peatland management? Well, I think there are three things that we have to focus on. Each offers opportunities, but there are challenges associated with each of these actions as well. First of all, we have to protect our undamaged peatlands, because in an undamaged state, most of those peatlands are still able to sequester carbon and to cool the climate. We need to develop mitigation incentives and techniques for people who are farming on peatlands. So we need to find ways that we can balance climate and livelihood security. And then we need to finally implement effective and enduring peatland restoration measures. Let's start with conservation. We want to protect the peat carbon store, we want to protect biodiversity, and we want to protect other peatland services. There are challenges associated with that. There's a body of science starting to emerge now, particularly from peatlands in Southeast Asia, which indicates that not all forested peatlands at the present time are continuing to act as a carbon sink. We're not entirely sure why that is, but it might have reasons that lie in large-scale land use change, at regional scale, hydrological changes at the catchment scale, and so on. So that's an area for science to keep pushing forward. Nevertheless, the emissions mitigation potential of forested peatlands is still far greater, of course, than any other disturbed peatland landscapes. We need to think about emissions mitigation where there is an interim need to balance livelihoods and climate security. And we know from research that we've done both in the UK and in Southeast Asia that if we can halve the water table depth in all our drained peatlands, then we can reduce global emissions from land use by something like 11.5%. So we need to bring water tables closer to the peat surface, while at the same time attempting to balance that with some form of livelihood use, livelihood protection. And this is challenging because it will require changes in land management. So water level management needs to be much more finely controlled. It needs knowledge of alternative wetland crops. It needs market development for those crops. And we need to consider the impacts that that change in land use might have on livelihoods. So we need to also think about food security. Some of these peatlands, particularly in Indonesia, play an important role in providing fresh fruit and vegetables into local markets. So there are all sorts of challenges there. And we need to balance the food security role that peatlands can play, at least in the interim, against their longer term potential role in climate security. And then finally, where it's appropriate to do so, we need to think about how to re-wet and how to restore our degraded. We need to do that because we want to protect the remaining peak carbon store. We want to reduce greenhouse gas emissions, rehabilitate the natural vegetation cover, the forest cover, and also linked to that would be a substantial reduction in fire risk. So re-wetting, re-vegetating will all bring down the risk of fire. And there is one very large project which is taking place in Sumatra at the moment, which is experimenting at a real large plot scale with the opportunities that raising water levels and planting native species can bring for all those elements that we want to, we see as positive elements of peatlands. So that's the INPREP project being run out of the National University of Singapore. There are, of course, challenges for restoration. There are challenges for peatland restoration wherever we are in the world, but particularly in tropical peatlands, because I think they're much more complicated, at least in terms of their species diversity, and there has been less research on tropical peatlands in terms of their restoration. We need to think about which tree species do we favour in restoration schemes, which traits. We need to think about, is it important in terms of the types of litter that are being produced? Some might be more recalcitrant and more able to accumulate in peatlands. And of course, we need to think about the below ground conditions as well, where there's a whole microbial community that we're only just starting to understand. We need to think how we can scale up from plots to landscapes. And we need to think as well about what role there might be for a slightly more engineered approach to restoration, depending on what our end goals are. It might be more efficient to restore using a more engineered approach. There is an urgency to all of this. We need to substantially cut our greenhouse gas emissions to the atmosphere by 2050. We understand from studies that I've been involved in that it may already be the case that global peatlands have shifted from being a net sink to a net source of soil-derived greenhouse gas emissions. And without rehabilitation, our drained peatlands could absorb quite a large portion of the emissions budget for keeping global warming below the Paris Agreement target of 1.5 degrees centigrade. So there's a real urgency to start to undertake restoration at scale, changes in agricultural landscapes at scale to reduce peatland emissions. We need to bring our drained peatlands back to net greenhouse gas neutrality, and in that there is a very key role that tropical peatlands can play. Thank you very much.
Thank you very much. Thank you very much, Professor Page. Now we have heard all esteemed speakers, and I must say that they have provided us with a wealth of knowledge and insights on various aspects of the tropics. I would like to open the floor to the audience. If you have any questions to our panelists, and please type them in the chat box and we will address them shortly. And to kickstart this question and answer session, I would like to firstly pose this question to all speakers. My question is, what is the common element in all presentations relating to the tropics? This is just top of my head, and I don't have the answer for that. So we have to digest the materials in order to say what is the most common element of all the 5 presentations. I would like to hear from any of the speakers if you have any quick summary on all the 5 presentations. Anyone would like to take up the challenge? What is the most common element of all the 5 presentations? Okay, maybe we'll come back.
I can have a go at that.
Okay.
But I would
go ahead.
say I think the common element is diversity.
Yes,
In
okay.
a sense, in that both in terms of ecosystems and approaches and everything, but we all talking on very different topics, and I think it's wonderful to see the diverse sort of science and approaches going on, and it's lovely to hear from my co-panelists. I've learned a lot in this session, so that would be my hot take: is diversity, both in terms of capacity approaches, but also in the systems itself.
Okay, thank you. Very good attempt, Dr. Tilly. I tend to agree with you. There's one, I would say, common element there. Biodiversity and diversity. Yeah, we have to take this aspect into all our activities and in our work and our research. Right. So I do have a set of questions to every speaker, and there are general questions. But since we have only 15 minutes left for question and answer, perhaps maybe I will address any questions from the audience, from the chat box. I saw Dr. Serena has responded to one question. May I see the chat box? Anyone that would like to pick up on the chat box? I don't see any. Right. If not, then I like to ask Dr. Tilly, first speaker. I think you have very good analytics. And also I have found the intensity of fishing around Penang very interesting. And I wonder how much this fact has been incorporated in the consideration of the proposed project. And I saw another slide presented earlier by this group called JEDI. And some or other, they only showed me the intensity of the fishing in the proposed reclaimed area, but not throughout the Penang and the surrounding area. So I found your data very, very encouraging in order to find whether we have alternative sites or not for such development. So that's my first question to you, Dr. Tilly. Right?
Thank you. Yeah, I would say that it can be a little misleading just because it's a snapshot of fishing activities around Penang, but I wouldn't. I'd just issue caution in thinking of it in terms of fishing intensity, because those are just overlaid over time. So that's like all of the fishing trips of a handful of fishers, but over the course of a year or two. So it might be misleading in terms of thinking of that as intensity. It's more just kind of highlighting areas of use. But certainly there are definitely opportunities to leverage simple and cost-effective technologies in Penang and throughout Malaysia, both in nearshore small-scale fleets and in offshore fleets. The digital approaches nowadays are phenomenal in what they can do in terms of even distant water, like trawling fleets, and looking at trying to eliminate transshipment and illegal fishing. And so there are some fantastic digital approaches, and we need to invest in those, I think, certainly in Malaysia, but throughout the tropics, because the enrichment that's, the potential enrichment in terms of information and knowledge about these systems is huge. So that's a quick response to your question.
Okay, Dr. Tilly, thank you for your quick response. And actually, I do have a second question to you about crocodiles and fishing in Timor-Leste. I'll come back to you since we're running out of time. I must give one question each to our speaker. The second one to Dr. Serena. Your work, I've been following your work all these years, and very impressive, and you try your best to come up how to incorporate such thing as design with nature, right? But all this development is very expensive, huh? You know what I mean? Very costly kind of development. But I also impressed the fact that you try to bring down such a kind of design how to incorporate nature into the design and architecture, the challenges for the low-cost housing, for the affordable housing. So what you see, the prospects of bringing this design with nature for the affordable housing or buildings in Malaysia?
I think it's very challenging because I think the way we've set up our affordable housing, I think the difference, of course, we can't help but look out at our neighbors, Singapore. We talk less about Thailand, and I'm sure Thailand also suffers to the same degree as Malaysia in terms of density and affordable housing. The fact that we don't build it, affordable housing down in Singapore is built by the government. It's different here. It's actually built by developers who basically are doing a land swap. So the requirements on the thermal properties of the building, it's overrun by the fact of the amount of housing and the price that we need to give. So I think that until we switch in terms of our mentality in how we're going to approach building affordable housing, that's the first thing. I think there was an interesting question amongst some of the audience with regards to, are we increasing the amount of greenery, etc. It's been very hard. I mean, I'm in the Malaysian Green Council as much as developing tools. There's nothing mandatory that is imposing a much bigger picture. I think that the main city centers are now trying to change that, and they're starting to think about low carbon. But the inertia to push it beyond a certain envelope, like Singapore, where there's a direct swap to amount of land and greenery that you must do. That means that if I develop on that land, I actually have to put the same amount of greenery on my building. That's not occurring yet here, but Singapore is working at a mandatory level. So I think we're a bit away from making those changes until we get the EE Act out and things like that out, which is delayed by 5 years now.
Yeah, thank you for your kind response. And actually, I do have a second question to you, but you don't have to answer. I found the heat island around Penang very impressive, the image, the heat island in Penang. Whether you have a similar images for Singapore and Klang Valley.
Absolutely.
Can share with us, later on.
It's not developed by myself. I think Dr. Tilly will know. I think City has done one for Penang, Ipoh, and Johor, the major cities where the bigger developments are happening. And you can actually see over time how much development and how much increase of heat island. Singapore, of course, has it, and they are actively, that's why they know where they want to increase amount of greenery and all the rest of it. They're taking a very scientific view on how they need to green their city, as opposed to ourselves. Not a lot of people know that, heat island increases by 5 to 7 degrees, depending where you are, because it's not shaded. Yeah. So, and then when I do present this to something like MITI and Maida, they say, what's the proof? Shamsani from University Malaya proved it more than 30 years ago when we started.
University Kebangsaan.
Yeah, the University Kebangsaan.
Yes.
He was the first to do these studies.
Yeah, that was back in 1972.
Correct.
Yeah. Okay, thank you. I will come back to you. I think we have like 7 minutes left. I have one question quickly to Professor Fatima. When we can expect your rapid test for dengue to be commercialized?
Yeah, that's a very difficult question to answer.
Yes, okay. You don't have to answer now. Difficult, but I think it will be very big help, I suffered malaria before, I suffered dengue, but I would tolerate malaria, but I won't tolerate dengue. You know what I mean? In terms of severity, So I think we're all looking forward to. I think there's been increase in the number of cases, incidents of dengue now, even in Singapore. All right. Okay. We'll come back to you on that, Prof. Fatima. You're doing very encouraging work. Professor Sunono. I never knew you had to take a vaccine for malaria. I'm not a biologist. Yeah, I learned something new from you today. Yeah. So is it a vaccine effective for malaria? Doesn't seem
Well,
to
there
be.
is no effective vaccine at preventing malaria. The vaccine that we have now, which is recommended, the two versions of it, will reduce your risk of getting malaria for the first 3 months, probably quite well, and then unless you get boosted repeatedly, this protection will fade. So it'll be a good vaccine for people who travel to areas where there's malaria, maybe tourists or military, but I don't think it's going to be a very good vaccine to give to people who are living in the tropics. Fortunately, in Malaysia, you don't have to worry too much because malaria is now confined to the few cases. I know that there are many, but the few cases where it's the malaria is coming from the monkey into the humans. And we certainly don't have a vaccine for this one. But with good development, malaria will disappear by itself without a vaccine, as it has done in Malaysia and Singapore.
Well, we use a lot of pesticides in the early years, huh?
Well, I don't know whether that goes with development, and development tends to go with economy and better economy goes with better health.
Yeah. But I had a friend from UC Malaya who got infected by malaria in the Rompin Reserve, right? So that was a very rare one. Okay, I don't have. I'm not sure whether Professor Page online. I don't think she is, right? Okay, among us, I recognize my colleague here, Dr. Lily Mengling. You have a comment on her presentation. She shared the hotspots in 2015 forest fire or hotspot during 2015 in the region. But of course, the map is a global map. But I remember I saw one of your presentation slides that in 2015, there was no hotspot at all in Sarawak. That's what I remember. Dr. Lulu Meling, are you there? Oh, yeah. Can you gain access to the mic? Okay, maybe she's not on the line there. I saw her.
I think she's not here, Dato.
Okay, right. Okay, maybe I wanted to share with you one of the mitigating measures that practiced widely in Sarawak, that when they convert the pit areas for agriculture, there is a requirement for soil compaction, and then that has proven to be very effective to prevent the converted pit area to agriculture will not catch fire. I think that's very invaluable work has been carried out and proven by the Tropical Pit Research Institute of Sarawak. So this is, I'll say, something I think Professor Page posing a lot of questions. What are the mitigating measures? And perhaps this is one of them we have found very effective. I think Professor Page also pointed out there are many disturbed pit areas not managed, right? Disturbed pit areas not managed, where during the flood, the flood waters not channel into the pit areas, but right, they should. This is one of the roles of the pit areas is to capture flood waters. But some other those areas have been disturbed and they're not receiving the flood waters. So during the dry season, they are prone to forest fire. So this is the one aspect of the management that we need the authorities to pay attention. So I have 2 minutes left. I'll give these 2 minutes left to any of the speakers. You like to pose any questions to your colleagues, your other speakers? Anyone? None? Okay. So now we come to the last part of our session this morning, our webinar this morning. So I don't think I'll do any justice to summarize all the excellent presentation. And I think what we learned today my favorite book is this Ian McHugh, Design with Nature, right? 1960. So I think whatever you do, you must have nature in mind. Yeah, I don't, the problem is we only expect the regulation to come in. Actually, in every activity, there's a big principle, established long time ago, since 1972. Prevention is better than cure, So I think I would like the approach shared with us by Dr. Sarina in terms of design. You start with the basic design. That means you take nature into consideration. I think that's what the Thai also, when they put up their houses, they are very cool, very nice, right? In their old houses. I think because of passive nature. So, okay, now there are many aspects of the architecture, engineering, natural resources, medicine that we have to really spend and work a lot more. I think we have more challenges in the tropics than in the temperate regions, I must say, because this is where the problems are and not much resources and expertise that we need to have in order to address all the challenges ahead of us. Yeah. So now 12 o'clock, so I would like to take this opportunity on behalf of the sponsors, the Mahathir Science Award Foundation and Academy of Sciences Malaysia. I would like to express our gratitude to all our speakers for sharing your knowledge and insights. Also, a big thank you to our audience for your participation and engaging questions, and some of them will repost on the chats. And we hope you found this webinar informative and inspiring, and let us continue to work towards the betterment of our tropical regions across the equator. Have a wonderful day. Thank you, Mas Ibuku, and Selamat Hari Raya Haji.
Thank you very much.
Happy International Day of the Tropics.
Thank you very much. Yeah, it was very insightful from everybody. I learned a lot from Dr. Alexander, Dr. Fatima, and Sununu. It's great to widen the horizon and see the invaluable work that you guys are doing. I take note about the island effects of fisheries. But not involved in that project anymore. So it'd be interesting if they've taken quite a lot of that into heart.
Yeah.
Likewise, nice to meet you all.
Yes. Who's talking just now? Sorry. Dr. Sinono, you wanted to say something?
No, I'm very, very pleased to have participated. And as I like for everybody else, many of the fields that were presented, I didn't know anything about, and it's very exciting to hear of them. Particularly interested into the point of care technology, which is moving very fast. I was involved a lot in developing PCR for detection, but only for scientific purposes. And it's nice to know that now what we used to take 1 or 2 days to achieve can be done in a few minutes, if not a few hours, on a lab, on a chip. I look forward to using these, but I'm coming close to retirement, so hopefully it'll come out soon.
So Fatima, I've shared it with a pharmaceutical company just to see if they're interested.
They should invest,
A Malaysian pharmaceutical company.
Yeah, Malaysian, yeah. I think a lot of scientists have developed the rapid test, but not commercialized. You know what I mean? So
I think from point of view, to get into commercialize, because it is not a one-man show, you need to have the industrial partner, the stakeholder like the government support, and the industrial for the technology transfer. So it depends. Just now, to answer Datuk's question, how fast it is. For the one that we already have licensed, then the one that is do not have interface with the patient, it will be very fast because you do not need to do the clinical trial with the patient. Then the certification, because it is a blood sample, but the one that on the monitoring with the patient interface, then it will take a little bit time. And we also need the Malaysian industrial to support and to have trust in our researcher in the university and to license our innovation. Because now I think the government, yesterday they already launched, MOSTI and also the other government's body, they already launched support to buy local product or medical device?
You know, Prof. Fatima, in 1993, I was in the expo in Munich, you know, and I came across the use of rapid test for, you know, any form of contamination, you know, say, you know, they use this chemical luminescence, you know. So I never seen that practice in a way. So you can check, the public health inspectors can just, you know, use a cotton swab, you know, wipe it on the table and put in this tube, you know, flashing some light. Then you know the table is contaminated or not clean, you know. So I never seen that practice anyway, you know. Yeah, I came across that one a long time ago. Have you seen that done anyway?
Not really. Yeah, not really. Yeah, commercialized.
Yeah, they release, you know, they got some energy, right? Electrochemical, they release it and they cause the fluorescence. Maybe Dr. Sunono can comment on that one. This is very rapid, test whether you know whether the table is clean or not. Yeah.
Well, what's the place where they use that sort of technology is in airport when they check to see whether you have any drugs in your luggage.
Oh, I see.
Or if you have any residues of if you fired a gun or if explosives. As you know, they kind of do a swab, put it in a machine, and then they tell you either you can go or they search you a little bit more thoroughly to see if you have any illicit substances.
That one is more on the electrochemical reactions, on the biosensor, It's already available.
Yeah, we are now going to non-formal session, okay?
Okay.
Non-formal session over. If the secretary can put up with us, maybe I would like to come back to Dr. Tilly.
He's actually just left, actually. He's got another meeting.
Just left, because
he's gone to another meeting, and I probably have to leave very soon.
I wanted to come back to him because I've been to Timor-Leste, right? And the reason why I went there, I wanted to offer them, because they're short of energy, right? Electricity. So I wanted to offer them my technology, ocean thermal energy, to generate power as water and, you know, food and things like that. And one of the challenges that I found, a lot of crocodiles, you know, in the waters. And a lot of incidents where fishermen, you know, I mean, they're eaten up by this crocodile. You know what I mean? So it's not very safe for waters. And I couldn't see anybody swimming. You know, and in fact, people not encouraged to swim, you know, along the coast. And I believe there's a local culture, you're not supposed to kill the crocodiles in Timor-Leste. So it's, you know, you're going to do a coastal development thing like that is quite a challenge, you know, how you address this issue. Yeah.
Dr. Serena, I have a question to you. I'm very impressed with your, you know, your architecture and ecology things, the design and so on. So I was thinking whether is there any design that you are looking towards for the medical, for the hospital environment, or how to have a very nice, you know, ecosystem for the hospital, to build up a hospitals. That's what I'm interested in.
I haven't done any hospitals. I'm doing a pharmaceutical. That's why I mentioned that I just shared some of your innovations to them. But I believe in the tropical environment. Singapore has actually done some interesting hospitals that is basically to do with health and well-being, transcending in the sense that there's a lot more urban greenery around, and that's affecting in a good way the patients, and so there's a bit better integration of that. So like one of the latest hospitals in Singapore, I think finished about 2 or 3 years ago. There's a lot better approach in terms of integrating. Quite often you find that, you know, the environment is affected just, you know, in terms of not expediency, but in terms of putting the association of spaces, like the clinics and the special consultation centers. But this one basically gives you a little bit more external environment. And the patients are basically getting, I wouldn't say well, but just in terms of their mental health, towards their own diseases is in an improved environment. The other aspect is, of course, they do change the hospital beds around, that there's a lot more view to the external. So these kind of things have come into play in terms of approaching health and wellness in terms of a design of hospitals as part of an integral part. So we're seeing some good stuff that's coming out from Singapore.
Yeah, that's very interesting, you know, like for the hospital and in considering the climate change in building it. It's very interesting.
Insulating
That's a
and
very high
shading.
topic now.
Insulating and shading is pretty key. I think, you know, university, despite it being quite an old, you know, the old university hospitals are designed back in the time I was born. They provided better shading. The only thing is, of course, the sort of upkeep and the orientation of the rooms and the bringing in intermediate spaces that provide some relief. You know, even if they're going to be in their wheelchair going out to sit or something like that. So there's a lot of that that's changing. Yeah.
Dr. Sanono, I think your malaria is very interesting. My innovation for the compact disc, it can be, because since it is a ELISA platform, it can do other, it can perform other diseases like malaria, you know, HIV and so on. It's a matter of changing direction and so on. Yeah.
Well, indeed, there's a lot of rapid tests today that are strip tests. And it's very interesting with they just basically work like the COVID test that we use, you know, where you kind of put a drop of blood or something from the nose. I'm interested that you can actually increase the sensitivity to levels similar to those of PCR, because one of the problems in Malaya is that a lot of the time the people who are infected are asymptomatic with very low levels. And these are very difficult to detect by microscopy. It takes maybe 10-15 minutes on each slide to find them. And PCR, of course, is a bit more costly, and it takes more time and it requires a laboratory. Therefore, it is only used under, let's say, scientific investigations. So if there's something where one can actually put a kind of a few microliters of blood and get an answer very quickly, I think that would be a major help to control programs. Because the people who have very low level parasthemias are the ones that are the reservoir, and it's the reservoir that's important. Of course, you have to treat the people who are ill, but they represent a very small minority of the people who are actually infected. And a rapid test like this, if you can develop it at a reasonable cost and deployable in the field, will be exceedingly useful.
Yeah, okay. The challenge from WHO is that whatever rapid tests available in the market, they still go for the gold standard for the ELISA. So that's the reason, you know, I do still go for the ELISA, because they will question, like, for the rapid test, for the electrochemical, you know, how fast, like the COVID, everything's just a paper base, but it's not gold standard for the ELISA. So that's the reason it's quite challenging for WHO. I mean, for these tropical diseases like malaria, all those things, they still want to go for ELISA based detection. So that's
I know, but it's easier to develop a test than to change the mind of the WHO, I'm afraid.
Okay, nice talking to you guys. Thank you very much for giving me
all the best, Prof. Fatima.
Yeah, thank you, Dato. Okay, thank you.
Thank you for the invitation.
Before you leave, I wanted to share with you that I always been very envious about the work of Pasteur Institute, you know. You know, and because lately one of my colleagues was working in Fiji, and she got into fish poisoning, you know.
Oh yes.
Yes, and then she got treated in Paris, Pasteur Institute. They're very impressive, huh?
Yeah, well, you know.
It's Secretera, you know this very severe.
Yeah, of course, it's to do with dinoflagellates.
Yeah, right. So
to the fish.
Yeah, so I know the French scientists have done a lot of work in the ocean.
Well, the Institut Pasteur has been at it for the last 100 years. So
yeah, right. And she survived, you know, and that was very nasty. Yeah, she survived. She was actually
It's a-
our ambassador to Fiji.
Good Lord.
Yeah,
Uh,
very
it's a
famous.
very toxic compound.
Very toxic. Yeah, many people die.
Yeah, indeed.
And in fact,
Very rapid.
yeah, in fact, in the Western Pacific, they're worried about this fish poisoning. They're very worried.
Yeah, because it's the algal blooms that are caused by
exactly.
easily they're promoted by increases of temperature.
Yeah,
and
temperature or nutrients in the water. Yeah, something like that. Yeah, right.
but we don't know very much why algal blooms develop or don't develop. I must admit, it's a
Yeah,
complicated
actually,
thing.
many scientists have learned it, and even it occurred in our region of the waters of Sabah and Brunei and Sarawak. And they say something to the upwelling of the nutrients on the bottom of the sea.
Yeah, we tend to know about it after it happens. We explain it, but we can't predict when it's going to happen.
We cannot predict. Yes, we cannot really, anticipate when they're going to hit us. There's no
Exactly.
early warning system for this. Yeah,
Exactly.
Yeah,
Indeed. Well,
you sound very familiar. Were you at the ISC in Paris meeting?
Which meeting?
International Science Council meeting in Paris in May.
No, I wasn't.
Yeah, because your name is very common, I suppose. Yeah.
Well, I collaborate with the University of Malaya, so the Department of Parasitology, and I visit Malaysia on a regular basis, except during COVID, where I was excluded from the visits.
So you work with Professor Louis?
I work with Yiling Law and Prof Fong, and people in the parasitology department.
Okay. Yeah, she's a well-known leading scientist. Yeah.
Very nice department, very nice university.
Yeah, right.
And so far, no ciguatera poisoning for me in Malaysia.
No. You get it in the Western Pacific.
Indeed. Like you also get it in the Caribbean.
Yeah, in the Caribbean, yes. In the Caribbean, yes. Yeah.
Good. Well,
so
thank you very much.
Nice that you could join us. I know early in the morning
I know it's just coming up to my waking up time, 6:15.
Yeah, right.
This is
time for breakfast, huh?
Indeed, I have to go and cook the breakfast now. No, I'm kidding. Good. Thank you very much for the invitation.
Thank you. Looking forward when you come to Malaysia, Kuala Lumpur, let us know. Yeah.
Yeah, indeed. Right. I will have to do that before the end of the year or early next year. Thank you very much.
Thank you very much.
Thank you. Bye-bye.
Merci beaucoup. Bye-bye.
Thank you, Prof. Dato' Baka. I find it very
insightful. Actually, there are a lot of questions posed by the participants. Can you get their names and answers and try to help to answer them? And there's one question. I raised the same question. The one participant asked Dr. Seridan about the images for different cities in Peninsula, the Heat Island.
Yes, I will email to them.
Thank you so much. Reference. Yeah. Okay, thanks to one and all. Many of you still stay back, Yeah, 100 of you still around. That's good. Yeah. So I have a good break, and tomorrow and easy on the road, right? If you travel, I know a lot of people rushing now out to go out station. Yeah. So selamat Hari Raya Haji.
Selamat Hari Haji, Dato'. Thank you so much.
Have a good break. Yeah. Right.
Yeah.
Thank you, Dato'.
Assalamualaikum. To the participants, thank you very much for attending this webinar from all over the world, making this program a success. I would like to remind the audience that this webinar is a pre-conference event of the International Conference on Tropical Sciences, TropSc2024. We have more pre-conference webinars coming soon, so please join us next time. And if you would like to watch the recording of today's session, you can check out our YouTube channel. The link is in the chat box. That's all from us today. Thank you and goodbye.